The linear correlation coefficient is denoted by R, and it measures the strength of the linear association between two variables. To find the linear correlation coefficient R, you can do it two ways. You can compute it by using the formula for R. That formula is below, and from it you can see it's not a formula you would really want to work with. It's very cumbersome and tedious to use. This formula here is typically not a lot of fun, but as you can see from this video title, we're going to be using it. The second way is we can use technology to find R. Using this method is actually quicker and easier as the program can do the computations efficiently. All you need to do is input the data values for the given problem and you're done. Again, we're going to be using the formula, so let's get into it. So first off, let's start off with what the formula says. R equals n times the sum of x times y minus the sum of x times the sum of y all over the square root of n times the sum of x squared minus the sum of x all squared. There's a difference between those two. And then times the square root of n times the sum of y squared minus the sum of y all squared. Again, these two things mean radically different things. We'll see them when we get to them. So, I'm going to keep the formula right here. And we're going to find the linear correlation coefficient R for this set of data. It's a small set, but it's easier to do it this way. So what I'm going to do is I'm going to start off by writing a table. So I'm going to say x, y, x squared, y squared, and then x times y. And so draw my table out like so. Write in my x values, so 1, 3, 6, 8. Y values 12, 8, 15, 10, and it must be in the order given to you. Do not change them because it will affect the answer later if you are switching around. So as it's given to you is as you should put it in. Now the first thing in here is I have x squared, so I'm going to take x and square it. So 1, then 9, then 36, 64. Now it says y squared, so I'm going to take my y's and square them. So 144, 64, 225, and 100. And now I'm going to take my x and y, each one, and multiply them. This is why you don't want to switch them. So 1 times 12 is 12, 3 times 8 is 24, 6 times 15 is 90, 8 times 10 is 80. Now this is all good, and I'm going to come back to the formula in just a second, but I'm going, well, I'll just zoom out just a little bit. I think that'll be good. So zoom out a little bit. And I'm going to do this. Sum of x's right here, which is going to give me 18 when I add all these up. Then the sum of y's, so I'm going to add all of these up. That's going to give me 45. Sum of the x squared, so again, sum of x squared is going to give me 110. I almost ran out of room there. Then I'm going to do the sum of y squared, and that's going to give me 533. And then I'm going to do the sum of x times y, which is going to give me 206. So that's not too bad. Now, I am going to use my formula. This is all the work I'm using, or I'm going to do to set up plugging in the numbers, because it's just easier that way. Now, the only thing I don't have from here is n. N is going to equal the number of pairs of numbers. So I have 1, 2, 3, 4 pairs of numbers. So n is going to equal 4. That's the last thing I really need. So now I'm going to take all these values that I know and plug it into this formula. So if you don't have this formula written down, I'd recommend writing it down, because I'm going to scroll down and we're going to write in all the numbers for this formula. So here we go. So R is going to equal 4 times 206 minus 18 times 45 all over the square root of 4 times 110 minus 18 squared. Now, if you're wondering where does 18 squared come in, remember, if you don't have it written down, that the formula says the sum of x all squared. So the sum of x, which is 18, then you square it. So that's where it's coming from. Then we're going to multiply it by the next part, which is going to be the square root of 4 times 533 minus 45 squared. And that's the sum of y's all squared. So there's your formula, all set up and ready to go. So just going to do the math. So let's see here, 4 times 206 is going to give me 824. 18 times 45 is going to give me 810. Do the square roots, so everything in the first square root is going to end up giving me 116, so square root of 116. And then everything in the second square root is going to give me 107, like so. And now I'm just going to do the top, which is a nice easy 14. And I'm going to do the bottom, which, you know, by this point, you can probably get away without using a calculator until now, but square root of 116 times the square root of 107, just throw in a calculator. And I'm going to go with the full approximation from my calculator, which is going to give me 111.4091558. And then just 14 over 111.4091558, which is going to give you 0. To 3 decimals, 0.126. So there is your linear correlation coefficient done by hand. And I'll just zoom out so we can see all the work that was written for this at one time. So I recommend if you do this, write a table out kind of like how I did here and put it in everything and do it that way. You know, it's, again, tedious, it's cumbersome, it takes a while, but if you do the legwork ahead of time and you have to do the formula by hand, this will make it a lot easier when you plug in the numbers into the formula at the end. But that's how you do the linear correlation coefficient by formula instead of using technology.